Hi everyone. In today's lesson from Unit 3.1, we'll be taking a look at the Pythagorean theorem, the converse of the Pythagorean theorem, and how we can find the area of a triangle. So you might be familiar with the Pythagorean theorem from a previous math course. In a right triangle, if we draw a quick right triangle here, we know that the two sides that make up the right angle are referred to as the legs, and the side opposite the right angle is called the hypotenuse. In the Pythagorean theorem, we're told that a squared plus b squared equals c squared. In other words, the sum of the squares of the lengths of the two legs is equal to the hypotenuse squared. So pretty much every time we ask, what's the Pythagorean theorem, people can usually tell us a squared plus b squared equals c squared. But remember that the a squared and the b squared have to be the legs, and c has to be the hypotenuse. And by the way, the hypotenuse is always the longest side in a right triangle. In our first two examples, we're going to use the Pythagorean theorem to find the length of each missing side. In our first two problems, we're going to round our answers to the nearest tenth, so we'll need the use of a calculator. And then in the next two, we're going to leave our answers in simplest radical form. Okay, so in number one, the two sides that are the legs are 4 and 5, and our hypotenuse is x. So plugging these numbers into the Pythagorean theorem will look like this. You can do 5 squared plus 4 squared and set it equal to the hypotenuse squared. 5 squared is 25, 4 squared is 16. Keep it equal to x squared. Add the 25 and the 16 to get 41. And then to solve for x, we take the square root. When I take the square root of x squared on the right-hand side, that just leaves me with x. Now, when I do the square root of 41, this is where we go to the calculator, and then we're going to get the decimal. And again, we need to round it to the nearest tenth. And the square root of 41, rounded to the nearest tenth, would be 6.4. In our second example, be careful, because now the variable that we're looking for, x, is one of the legs and not the hypotenuse. Okay, remember, in the Pythagorean theorem, it is a squared plus b squared equals c squared, but you don't always put the variable by itself on one side of the equation. The hypotenuse always goes by itself. So plugging these numbers in, and the variable, plugging that in, we're going to write x squared plus 6 squared is equal to 10 squared. Again, it's the hypotenuse that has to be by itself. So the sum of the squares of the two legs will give us x squared plus 36, and the hypotenuse squared gives us 100. Subtract that 36 from both sides, we get x squared is equal to 64, and we're ready to take the square root to solve for that missing leg. So take the square root of both sides, and we get x is equal to 8. No rounding needed because it was a perfect square. Okay, in 3 and 4, we have to write our answers in simplest radical form. Okay, so remember that we want to be careful. Look at where the legs are, where the hypotenuse is, and think before we plug these numbers into the Pythagorean theorem. So we want to do the sum of the squares of the two legs, so do x squared plus 6 squared, and set it equal to the hypotenuse squared. So you have x squared plus 36 is equal to 144, because that's 12 squared. Take and subtract 36 from both sides. We get x squared is equal to 108. Now we're going to take the square root of both sides in order to solve for x. So the square root of x squared does give us x, and now we've got to simplify the square root of 108. So let's find a perfect square that divides into 108. I know that 4 works, but you want to try to find the largest perfect square that divides into 108, and it's actually 36. And 36 goes into 108 3 times. So there's my perfect square. 36 times 3 is 108. Square root of 36 gives us 6, and we're left with 3 inside the radical. Nice, exact answer, no rounding in this case. Okay, and number 4, we'll set this one up as x squared plus 4 squared, and set it equal to that hypotenuse squared. So it's equal to 6 squared. So we have x squared plus 16 is equal to 36. Take and subtract 16 from both sides, and we have x squared is equal to 20. Then to solve for x, we need to take the square root of both sides of the equation. The square root of x squared gives us x, and now we have the square root of 20 on this side. We're going to simplify that. So 20 factors into 4 times 5. Take the square root of 4, you get 2, square root of 5. That's it. Okay, so we know that if we are given a right triangle, we can use the Pythagorean theorem to find a missing side. But now we're going to take a look at trying to prove whether or not a triangle is a right triangle based on the sides. So it's kind of like working in reverse, okay, because we have the converse of the Pythagorean theorem, which says if the square of one side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. But we can take this a few steps further and not only prove that a triangle is a right triangle, if it's not a right triangle, we can prove that it's an acute triangle or an obtuse triangle. Okay, so imagine that we have a triangle, and I'm going to put it up here. And let's say that the vertices are A, B, and C. We use capital letters for those angles. And so the sides opposite those angles would have lowercase letters to represent them. So you have side A, side B, and side C. Okay. So if you have a triangle and you plug the numbers into the Pythagorean theorem and you get that it is exactly c squared is exactly equal to a squared plus b squared, then that means that triangle ABC is a right triangle. So let's check out some numbers. Let's say that I tell you that the lengths of the sides of the triangle are 3, 4, and 5. And we want to know if this triangle is indeed a right triangle. Well, first of all, we need to know that C would be the hypotenuse because it's the longest side. Right? 5 is the biggest number. It's the longest side of the triangle. The hypotenuse would always be the longest side because it's opposite the largest angle. So the largest number in your list is going to be plugged into the equation for C. So let's check this out. Let's do 5 squared and see if it is really equal to 3 squared plus 4 squared. 5 squared is 25, 3 squared is 9, 4 squared is 16, and so check it out. 25 is exactly equal to 25, and that proves that this triangle is a right triangle. Now, if you plug the numbers into the Pythagorean theorem, and instead of it being exactly equal to c squared, if you find out that c squared is less than the sum of a squared plus b squared, then that means that your triangle ABC is acute. Right, that means that all three angles would be less than 90 degrees. So let's check this out with another set of numbers. Just going to put a line here. All right, so the numbers that I want to work with here are 4, 5, and 6. Again, 6, if this were to be a right triangle, 6 would have to be the hypotenuse. So 6 is going to go in for C. So we're going to do 6 squared, and we're going to compare it with a question mark here to 4 squared plus 5 squared. Because we want to see if it's equal to 4 squared plus 5 squared, less than it, or greater than. So 6 squared is 36, 4 squared is 16, 5 squared is 25. So in the end, we're going to have 36 is less than the sum of 16 and 25, because 16 plus 25 is 41. So since 36, that's our c squared value, is smaller than 41, our triangle, whose sides are 4, 5, and 6, would be acute. Okay, in the last scenario, if we show that c squared is greater than the sum of a squared plus b squared, then our triangle, ABC, will be obtuse. So one last set of numbers to check out. Let's say our numbers are 3, 4, and 6. So again, put the biggest number in for c, so we do 6 squared, and we're going to see if this is indeed greater than 3 squared plus 4 squared. 6 squared is 36, 3 squared is 9, 4 squared is 16, and 9 plus 16 is 25. So yes, 36 is greater than 25. So c squared is greater than a squared plus b squared. So our triangle is obtuse. Okay, finally, our last piece of today's lesson involves finding the area of a triangle. You may recall from a previous math class that the area of a triangle is equal to 1/2 the product of the base of the triangle times the height of the triangle. You might know this better as area equals 1/2 base times height. Or you can also write it as area equals the product of the base and the height divided by 2. They both mean the same thing. So when we're working with a triangle like we have below, actually there are 2 triangles here that are right triangles, and they make up this third larger triangle. We're asked to find the area of this triangle to the nearest tenth. It says you'll need to use the Pythagorean theorem to find the missing side lengths, and you can round intermediate values to the nearest tenth. Okay, so if we want to find the area, we have to take 1/2 times the base times the height. Remember that the height has to be perpendicular to the base. So there's the right angle. So I labeled this missing side length right here as the height. Now that height is perpendicular to the base. The base isn't just the 3, but the base would be this whole side. So we have some work to do to find those missing pieces. Start with the little triangle first. We're going to set this up in the Pythagorean theorem. This is our hypotenuse. So we want to set it up as 5 squared is equal to h squared plus 3 squared. 5 squared is 25. That's equal to h squared plus 9. Subtract 9 from both sides of the equation, and we're left with 16 equals h squared. Take the square root of both sides, and it works out really nicely that the height is equal to 4. Okay, so thinking about finding the area of this triangle, so far we know that we have area equals 1/2. We still don't know the base, but now at least we know the height. We can put 4 in there. Okay, we're going to move this up a little bit. I'm going to move it up, and then we'll work on finding this missing side in the other triangle that I'm going to call x. Alright, now we've got some room to move here. So in order to find the base, that's the whole length of that missing side, we have to find the value of x and add 3 to it. So to solve for x, we're going to work with this little triangle on the left, and we would set it up in the Pythagorean theorem. This is my hypotenuse, so that 8 is going to be by itself. I'm going to do 8 squared is equal to x squared plus 4 squared. So we had to find the height, we had to find that 4, so that now we can solve for x. 8 squared is equal to 64. That's equal to x squared plus 16. Subtract 16 from both sides, and we end up with 48 is equal to x squared. Now this is a case where we want to go back to the directions, and it says we can round intermediate values to the nearest tenth. An intermediate value is like an answer that you find along the way. So instead of simplifying this radical, because we're going to take the square root of both sides now, we're going to go to the calculator and take the square root of 48 on your calculator. When you round it to the nearest tenth, it's 6.9. Okay, so this is 6.9, and so that means that our base would be equal to 6.9 plus 3, or the base is equal to 9.9. Okay, plug that number in up here. We're going to have area equals 1/2 times the base, which is 9.9, times the height, which is 4. And you can take some help from your calculator if you want. And the final answer would be 9.8. And we're going to say square units on there because it is an area, and area is measured in square units. So 19.8 is the final answer.